If the terms decrease, clearly converges.
I mean,
If the terms decrease, the series clearly converges.
do you mean if terms decrease?
If the terms decrease, if the limit of the terms goes to 0, the series will clearly converge. No. What's the limit as n goes to infinity of both of those series?
Infinity.
0. They're both eventually approaching the horizontal asymptote. But the bottom one approaches its singularity very quickly. So therefore,
Converges.
it converges. The top one, even though the terms go to 0, it does so slowly that the series diverges. Okay? All right. I want to give you some more examples here. And I don't want to start, there's another part of alternating series, but we can do that tomorrow. What I would like to do is this. I'm going to give you something, and I'm going to put them on the board. And I want you to tell me, just tell me what test I would use. Okay? What test we would use. And there may be more than one. So I want you to think about it before you yell out, because we may have either disagreement or we may be saying the same thing. Okay? This one right here.
Divergent test.
Or one.
Isn't that just
The numbering system could use some symmetry, but anyway. Okay, I'm telling you right now you have enough skill to be able to show convergence or divergence, and by what tests. Now, I'm not asking you to add those up. Okay? You can write them down if you want to. We can just discuss it. I mean, I'm kind of pulling them off an assignment you're going to get. So, you'll see them later. Any thoughts on the first one?
well? It obviously diverges because the top increases faster than the bottom.
Right. Now, that's a little bit vague mathematically, right? That's not really a proof necessarily. So, using calculus, I agree it diverges. And I also think it's very clear. But I need to prove it using some sort of test. What test?
Divergence test.
Yeah, divergence test. Yeah, how would I show that? Isn't that what I should be doing every time? Right? Limit into infinity. The fastest growing function that we have, that we know about, over itself a fast growing function, but which one grows faster?
And factorial.
Top, in factorial. So therefore, I know for a fact that's not going to go to 0. Therefore, my answer
Diverges.
diverge by
DT.
nth term test or divergence test. I don't care. I suppose on a quiz or a test, it might be a good idea to make that out as practice for the AP exam. These are notations for us, but. And there are 2 tests that start with the letter R, which we'll start learning on Friday, so
Oh boy.
I can't use R test. Okay?
Ratio and root test.
Ratio and root test.
Fun.
All right, what about the second one?
That one.
Ratio. Limiting comparison.
Yeah, I'd say limiting comparison. The clue there is that I have polynomial over polynomial, and I can compare the degrees. So what am I comparing this to?
1 over n.
Right, 1 over n. Now, what do I know about this? So right here, I compare to that. What do I know about that? What is it?
It's P test.
It's
That's
a p-series,
divergent
and p
because
is
equal to
equal
1.
to 1.
So it's divergent.
It diverges, yes. It diverges. Remember, if p is less than or equal to 1, the series diverges. So right here I have a divergent p-series. So I highly suspect that this also diverges, but I have to show it. Yeah. And the limiting comparison test, the LCT, would look like this. You have this divided by that, which is multiplied by the reciprocal. Now what do you get on top?
N cubed.
N cubed over 3n cubed. And now we could use our horizontal asymptote rules. What is the final answer?
1/3.
1/3. Now that is not the sum necessarily, but that is 1/3. And with limiting comparison test, I'm supposed to be getting a positive finite answer. So what is my conclusion? By the way, if I get a positive finite answer, this series will behave exactly like the one I compared it.
So by LCT
Yeah?
series diverge.
Diverges by LCD, or whatever, I realize that. Okay. What about that one? You recognize it? It's a little bit tricky. I'll give you a hint, I can find the sum of this one as well. That's it.
Yeah.
Any guesses?
Alternating?
No negatives.
Oh, you're right.
Can't do P series there.
No, not p-series. Because with p-series, it's the exponent that's a number and the base is no, because the denominator is growing faster because it has a bigger base. This is actually a geometric series. But I have to rewrite my numerator. 3 to the n plus 1 power is 3 times 3 to the n.
Huh. Oh, okay. Yeah.
See?
Yeah.
And if I was to multiply those together, I'd get n plus 1. So now I have 3 times 3 to the n over 4 to the n, which is 3 times 3/4 to the n. There's my a, there's my r. And since r is less than 1, this converges, and I can even find the sum. 3 over 1 minus 3/4, or 12. Right? The geometric series sometimes are a little tricky to find. The clue that I saw, both I have numerical bases and they both have powers. Okay? They're not superpowers. Okay. Hey, don't give up on this. Don't give up on this.
Oh, too late.
All right?
Nah, kidding.
Hey, this